Hello everyone. Welcome back to Learn Smart with Shweta. In this video, we are continuing with the chapter Machines from Concise Physics for ICSE Class 10. In this exercise 3B, we will solve 10 numericals based on pulleys, including the application of mechanical advantage, velocity ratio, and the basic principles of pulley systems. Let's solve each question step by step and understand the concepts along the way. So let's get started. Let's look at the first question. A woman draws water from a well using a fixed pulley. The mass of the bucket and the water together is 6 kg. So this is a fixed pulley and mass of the bucket and the water together is 6 kg, which means load. Load is equal to 6 kg into 10. Because they have said take G is 10, so 60 Newton. And water, the force applied by the woman is 70 Newton, which means effort. Effort is how much? 70 Newton. And the force applied by the woman is 70 Newton. Calculate the mechanical advantage. So for mechanical advantage, we have to remember that the formula is load upon effort. So we will do load upon effort. Now load is 60 and the effort is 70. 60 upon 70, solve and you will get the answer. If we solve, we will get this 0.857. So the mechanical advantage is 0.857 and this is how simply by doing load upon effort we can calculate. Let's see the next question. Now question number 2. Question number 2 is a fixed pulley is driven by a 100 kg mass falling at a rate of 8 meter in 4 seconds, which means that this is the effort. So effort given is 100 kg and we will convert it to, they are told take 1 kg as 10 Newton. So we will get it as 1000 Newton. So this is the effort because the fixed pulley is driven by a 100 kg mass falls on it and it goes at the rate of 8 meter in 4 seconds. Lifts the load of 75 kgf. So load we will write 75 kgf, which is, we will convert to Newton. So 75 into 10, which is 750 Newton. Now what? The efficiency. So first we have to calculate the power input to the pulley. So how to calculate power? Now, there is one formula for power which you have to remember. P is equal to F into V. What is F? F is the force. And what is V? V is the velocity. So, power, they have told power input to the pulley. What is the power input? So, the effort, that is 1000 Newton is applied. So, that is the force. And what is the velocity? So, see, velocity they have given that it falls at a rate of 8 meter in 4 seconds. So, the velocity is 8 upon 4, which means we will get 2000 watt. So, for calculating the power, we have to remember that since here they have given the velocity, we can use the identity F into V and we can calculate. Next is, they have told efficiency of the pulley. Now, we have to remember the formula that mechanical advantage equals to velocity ratio into efficiency, right? And what is mechanical advantage? Load upon effort. Load here is 750 and effort is how much? 1000. And velocity ratio, for a fixed pulley, we have to remember that velocity ratio is 1. So we will take 1 and into efficiency. So efficiency they are getting how much? 0.75. 0.75 is the efficiency that we get. 750 upon 100, you will get 0.75. And now they are telling height to which the load is raised in 4 seconds. What is the height to which the load is raised? This was number B. We calculated the power, number A, and height to which the load is raised. How do we calculate the height? So, there is again a formula that velocity ratio equals to, what is velocity ratio? So, it is distance moved by the effort upon distance moved by the load. So, we write dE by dL.
Now we can see that they have given the fixed pulley is driven by a 100 kg mass falling at a rate of 8 meter in 4 seconds. So this is the distance moved by the effort. So 8 meter in 4 seconds. So 8 meter is the distance moved by the effort, and velocity ratio we have to remember that for a fixed pulley it is 1. So 1, and let's say we don't know distance moved by the load, let's take it as x. So we will get x as how much? We will get x also as 8 meter. So the distance moved by the height to which the load is raised in 4 seconds will be same as the height moved by the effort. So it will be 8 meter. This is how you can solve this question, right? Let's see the next question. Now question number 3 says, in a block and tackle system consisting of 3 pulleys, so a load of 75 kgf is raised. They have told that load is 75 kgf with an effort of 25. Effort is equal to 25 kgf, and we have to calculate mechanical advantage. So mechanical advantage is equal to load upon effort. That same formula we will apply, and load is 75, effort is 25. So we will get 3. So mechanical advantage equals to 3, and we got first one. Then is the velocity ratio. So for block and tackle system, you have to remember that the value of the velocity ratio is n. N is the number of pulleys. Here the block and tackle consists of 3 pulleys. So velocity ratio is always equal to the number of pulleys. So velocity ratio will be equal to 3 because there are 3 pulleys. We have to remember that. Next is efficiency. How to calculate efficiency? So there's a formula which we have to remember. We have used in the previous question also. Mechanical advantage is equal to velocity ratio into efficiency, and you have to calculate efficiency. So we will do mechanical advantage upon velocity ratio, and we will get efficiency. So mechanical advantage is 3 and velocity ratio is also 3. So we get the efficiency as 1, which means 100%. So the efficiency of the machine is 100%. Of this block and tackle system, efficiency is 100%. So simply by using mechanical advantage as load upon effort, and you have to remember that in block and tackle system, the velocity ratio equals to n, that is the number of pulleys. So it will be 3, and then you can use the formula, this formula, mechanical advantage is equal to velocity ratio into efficiency to calculate the efficiency, right? Let's see the next question, question number 4. Question number 4 is again a block and tackle system has 5 pulleys. So if an effort of 1000 Newton, let's write effort is equal to, if an effort of 1000 Newton, downward direction to raise a load is equal to 4500 Newton. And what? We have to calculate the mechanical advantage. So mechanical advantage, we can simply do load upon effort, and we will get 4500 by 1000, which will come as 4.5. We got mechanical advantage. Now we have to calculate velocity ratio. So again remember, number of pulleys is 5. So velocity ratio will be equal to 5. Right? You have to remember that. And efficiency of the system. So same formula we will apply. Mechanical advantage is equal to velocity ratio into efficiency, which means mechanical advantage we have got 4.5 and velocity ratio is 5. This is efficiency. If we solve this, we will get 90%. So efficiency is equal to 90% is the answer. So for block and tackle system, you have to remember that always velocity ratio is equal to the number of pulleys. Mechanical advantage we will use load by effort we will get, and for efficiency if we have to calculate, we will use the formula mechanical advantage is equal to velocity ratio into efficiency, and we can get it very easily, right? Let's see the next question, question number 5. So in question number 5, draw a tackle to lift the load by applying the force in the downward direction. So we have to draw the tackle. How to draw the tackle? So we can see in the upper block there are 3 pulleys, lower block there are 2 pulleys. So the thread will go that from the lower block to the upper block, and this is how you have to draw. This is how you have to draw. Mark in the diagram the direction of load and effort. So this is load. Load acts in the downward direction and effort acts like this, and here is the tension. So we have marked that. If the load is raised by 1 meter, through what distance will the effort move? So remember, in block and tackle system, and here we should draw all the arrows. You know, here like it is given in the book, all these are tensions cap on the rope. These are all, the load is balanced by the 5 tensions. So if the load is raised by 1 meter, remember, if the load is raised by 1 meter, the effort moves by n times. The number of pulleys 5 over here, so the effort will move by 5 meter. If load moves by 1 meter, then 5 times the distance moved by the load, the effort moves. So distance moved by the effort is 5 meter. We have to remember that. And number C, state the number of strands of tackle supporting the load. So this is the load, and since there are 5 pulleys, there will be 5 strands of the tackle. So it will be 5. And what is the mechanical advantage of the system? So how do we calculate the mechanical advantage? So we will simply do mechanical advantage is equal to load upon effort, but here we can see that load is balanced by the 5 tension forces, you can see. So mechanical advantage here, it will be load upon effort. So here load is equal to, load is supported by the 5 strands of the tackle. So we write 5T, and effort is how much? Effort is equal to T. So we get mechanical advantage as 5. This is how we calculate the mechanical advantage, and we get the mechanical advantage. Let's see the next question, question number 6. Now the question number 6 is, a pulley system has a velocity ratio 3 and an efficiency of 80%. Draw a label diagram of this pulley system and calculate the mechanical advantage. So if velocity ratio is 3, we can draw the diagram like with 3 pulleys. 2 pulleys up in the top block and 1 below. We can draw the hooks, and here you can draw the load. This is the load. The down arrow we should show for the load. Here you should draw the support, and now you should draw the tackle. How will the tackle will go? That means the thread will go. So since there are more number of pulleys in the upper block, we have to draw it from the lower block to the up, and this is how it will be. And we have to show the arrows. So it is supported by 3, the load is supported by 3 T forces, tension forces. This is the effort, and here is the, again, that tension force. So this is the diagram that we can draw. This is how it would, and of course there will be connection between the pulleys. So they have told us that calculate the mechanical advantage of the system, and pulley is 80% efficient. So we have to remember the formula that we used before. We will write that mechanical advantage equals to velocity ratio into efficiency. And velocity ratio, since there are 3 pulleys, it will be 3. And for efficiency, it is 80%. We will write 80 upon 100. And if we solve this, we will get 240 upon 100, which will come as 2.4. 2.4, and that is our mechanical advantage. Now they have told calculate the effort required to raise a load of 300 Newton. How do we do that? So we will use the formula mechanical advantage is equal to load upon effort. And mechanical advantage we have calculated 2.4. So we will write 2.4 equals to, load is 300 and effort we have to calculate. So just solve it. Effort is equal to 300 upon 2.4. Solve and get the answer. So we will get 125 Newton. this will be the effort required, and this is how it can be calculated. Let's see the next question, question number 7. So look at this question. In figure 3. This figure shows a system of 4 pulleys. We can see the upper 2 pulleys are fixed and the lower 2 are movable. Draw a string around the pulleys. So there are there are 2 pulleys in the upper block and 2 pulleys in the lower block. We have to draw the string. So now we will take the string from upper block to the lower block. So we will draw the string like this. And this is how we will get. Then draw a string around the pulleys, also show the point of application and direction in which the effort is applied. So this is the effort, and here we will show that the effort is balanced by 2. This is load. We should draw the down arrow for load, and we should also draw the tension forces which acts on the string. So T, T, T and T. Right? Now what is the velocity ratio of the system? It is a block and tackle system. Number of pulleys is 4, so velocity ratio will be equal to 4. We have to remember that. How are load and effort of the pulley system related? So how is load and effort related? We know that load is balanced by 4T and effort is equal to T. So see, load is equal to 4T and effort is equal to T, which means we can write that load is equal to 4 times the effort, because effort is equal to T. So this is the relationship. How load and effort of the pulley are related. We can write that load is equal to, because load is equal to 4T. We can see load is balanced by 4 tensions and effort is balanced by equal to tension 1T. So we can write load is equal to 4 into effort. And then what assumption do you make in arriving at your answer in part C? So when we are doing, what is the assumption we are making? Now this is very important question, that we have assumed, because we are telling load is 4T and effort is T. So we have assumed that there is no friction between the strings. Very important point, we have to write that we have assumed there is no friction in the pulley bearings, and weight of the lower block we have taken that it is negligible, because otherwise in the actual system, because of the weight, the efficiency is not 100%. So we have assumed that weight of the lower block is negligible and effort is applied downward. So effort anyways is applied downward. We can see effort we are applying downward. So we have assumed that, we have to write it. So in this question we had to draw the strings. We have drawn. When you draw, you will mark the load, direction of the load, effort, then T, all the tree and the T. And the arrows you should draw properly. Velocity ratio will be equal to the number of pulleys. So 4 pulleys are there, therefore the velocity ratio will be 4. How are they related? So we know that load is balanced by 4T. So we write L is equal to 4T, and look, effort is equal to T. So load we can write that, therefore load is equal to 4 into effort. And what is the assumption? This is a very, very, very important question. What are the assumptions we are making? So we are assuming that there is no friction. Where no friction? In the pulley bearings, and weight of the lower block we are taking negligible, and effort that we are applying, it is in the downward direction. So you have to remember these points for writing in the examination. You should write these points. Let's see the next question, question number 8. Now question number 8 is, figure shows a block and tackle system of pulleys used to lift a load. How many strands of tackle are supporting the load? We can see there are 4 pulleys. So how many strands of tackle? It will be 4. The number of strands of the tackle is always equal to the number of pulleys, so it will be 4. Draw arrows to represent tension in each strand. So arrows will be just like this. So up arrows and this, and effort is downward and it is balanced by an up T. So this is other. So we should write T, T, here also T and T. So what is the draw arrows to represent tension? We have done that. What is the mechanical advantage of the system? So mechanical advantage, how do we write? So load is supported by 4T. So 4T upon effort. Effort is equal to 1T. So which becomes equal to 4. So mechanical advantage will be 4. Then when load is pulled up by a distance of 1 meter. So again you have to remember, if load is pulled up by a distance of 1 meter, effort goes down by n times. N is the number of pulleys. So there are 4 pulleys. So effort will be 4 meter. If load rises up by 1 meter, the effort will go down by 4 meter. It depends on the number of pulleys. 4 pulleys, so it will go down by 4 meter. How far does the effort N move? It moves 4 meter. 4 times of the load, and 4 times means N times number of pulleys N. So it is 4 meter. Then E, how much effort is needed to lift a load of 100 Newton? So mechanical advantage is equal to load upon effort, and mechanical advantage we calculated 4. So we can write that effort is equal to load upon mechanical advantage, and load is how much? 100 Newton. So 100 and mechanical advantage is 4. So 100 upon 4 we will get 25 Newton. So how much effort is needed? It will be 25 Newton. Effort required is 25 Newton. We can calculate simply by doing load upon effort. Here efficiency they haven't mentioned that what is the efficiency. So we will take it as ideal situation and 100% efficient. So we are getting load by effort and we are getting 25 Newton, right? Let's see the next question, question number 9. Question number 9 is, a block and tackle system has the velocity ratio 3. Draw a label diagram of the system indicating the points of application and the directions of load and effort. So it is the similar question we did, but let's solve. It has velocity ratio 3 and they are telling that draw a label diagram system indicating the points of application, and since the velocity ratio is 3, so it will be, there will be 3 pulleys. Block and tackle system we are taking. There will be 3 pulleys. This is the support. Here there will be the load. We will write a down arrow with the load. We should draw 2 hooks over here and we should show the string. Since upper block contains 1 more, so the string will go from down to up. This is how effort arrow we will show, and here we will show a T. All the tensions we will draw here, here and here. We should write T, P and T. We have drawn. So draw a label diagram of the, and these we will show connection between the pulleys. Draw a label diagram of the system indicating the point of application. So this is the E is the, we will write point of application of the effort. So point of application and the direction of the load and the effort. So direction of the load we are showing down, and this is the point of application of effort. Right? Now a man can exert a pull of 200 kgf. What is the maximum load? So this is the effort. So we will write effort is equal to 200 kgf. And what is the maximum load he can raise with this pulley system? If its efficiency is 60%. So efficiency is only 60%. How do we calculate? We have to calculate the load. Now we know that mechanical advantage is equal to load upon effort. Now here it is said that the pulley is 60% efficient. And velocity ratio will be equal to 3 because in block and tackle system, velocity ratio is equal to the number of pulleys. So, what we will do, we will first calculate the value of mechanical advantage using the formula mechanical advantage is equal to velocity ratio into efficiency. So, we will write mechanical advantage is equal to velocity ratio is 3 and efficiency is 60%, which means 60 upon 100. Which means we will get 180 upon 100, so which is 1.8. So we got the mechanical advantage as 1.8 and we have to calculate the load. So we will write mechanical advantage is equal to load upon effort, and 1.8 equals to, effort is 200 kgf. So we will write load upon 200 kgf, so into 10 we will do. So we will get load as 18 into 2 is 36. We will get it as 3600 Newton, or if we write in kgf, it will be 360 kgf. Right? So using the formula mechanical advantage is equal to load upon effort, we can get that. And now they are telling if the effort end moves a distance of 60 centimeter, what distance does the load end move? So how do we calculate how much distance? So we know that velocity ratio for B, we can write velocity ratio is equal to distance moved by effort upon distance moved by load. There are 3 pulleys, so velocity ratio is 3. 3 is equal to, and if the effort end moves 60 centimeters, so distance moved by the effort is 60 and distance moved by the load we don't know. So distance moved by the load will become 60 upon 3, which is 20. We will get 20 centimeter. So distance moved by the load will become 20 centimeter and you can calculate. So we have to also remember that velocity ratio formula is dE by dL, distance moved by the effort upon distance moved by the load, and we can get the velocity. We can calculate distance moved by the load by using that, right? Hope it is clear. Let's see the next question. Now in question number 10, you are given 4 pulleys and 3 strings. So 4 pulleys and 3 strings. Draw a neat and labeled diagram to use them so as to obtain a maximum mechanical advantage equal to 8. So there are 4 pulleys and we need a mechanical advantage of 8. So it is not block and tackle system. Then it is a different system where there is 1 fixed pulley and 3 movable pulleys. In your diagram, so we have to draw that, and in your diagram we have to mark the direction of load, effort and tension in each strand. So what is the diagram that we should draw? See, this is the diagram that you have to draw. There is 1 fixed pulley and these 3 pulleys are movable pulleys. And these are the 3 strands and this is 1 fixed. So you are given 4 pulleys and 3 strings. So these are the 3 strings, 1, 2, 3 strings. And this is the diagram that they are asking you to draw. Maximum mechanical advantage you will get. So in this case, we get the maximum mechanical advantage, and mechanical advantage is equal to 2 to the power of n. N is the number of pulleys, variable pulleys. So here you will get the mechanical advantage of 8 therefore. And mark the directions of load. So see the direction of load you will mark with a down arrow like it is given over here. So down arrow should be mentioned. And mark the direction of the load and tension in each string. So this load is supported, balanced by these 2 tension forces T1, T1. Then T1 is balanced by T2 and T2. T2 is balanced by T3 and T3 tension forces, and effort is equal to T3. So this is the diagram that you have to draw. And what assumption have you made to obtain the required mechanical advantage? What is the assumption that we are making? So we have to write that the 3 movable pulleys are there and 1 fixed pulley is there, only there. We will get a mechanical advantage of 8. So this is that system and we have to remember. So this diagram you have to draw for this question, right?
So that brings us to the end of exercise 3B, where we solved 10 important pulley-based numericals. I hope these solutions have helped you understand how to apply the pulley formulas and solve such questions confidently in your exams. Do remember that the edition of the book you are using may contain 1 or 2 additional questions. Keep practicing and I will see you in the next video with more ICSE Class 10 physics questions.